Hello, my name is John Bannon. I'm an attorney and philosopher. In today's video, I'm going to explain why superdeterminism is supported by quantum randomness. Now, at the quantum level, uh, which is the level of molecules, atoms, subatomic particles, everything is inherently random and probabilistic. Uh, this behavior at the quantum level is described by quantum mechanics and quantum field theory, and it involves a wave function of superimposed possible states where the resulting definite state is inherently random, although based on a probability distribution, and somehow brought about by a measurement or observation which collapses this wave function, creating a definite state of reality. Now, because our macroscopic reality is comprised of all these tiny quantum particles, billions and billions of them, then our macroscopic reality is also ultimately based on this inherently random physics. We don't notice it as much because what happens is when you're talking about billions and billions of subatomic particles or particles, their inherently random characteristics get averaged out. And as a result, you end up with, at our level, something that seems to be a solid object or something that stays put over time and can move and behaves according to deterministic laws of physics. But the truth is, that's just because of the averaging out of the inherently random quantum behavior that's going on at the lowest levels of reality. Now, quantum randomness is uncaused, meaning it does not have a deterministic cause based on a prior cause. So, all reality, including our macroscopic reality, is ultimately uncaused, which would not be the case if cause and effect in physics were real. So, because all of reality is actually based on uncaused random quantum events, then that explains why there is no cause and effect in physics, which is what superdeterminism says. Now, you could wonder about, well, what about a spontaneous coming into existence of a random quantum event as opposed to something being uh, brought into existence through cause and effect in physics? An example might be the decay of a radioactive atom, the timing of the decay of that radioactive atom releasing a photon or some electromagnetic radiation. So that would be called acausal physics, but it's what it really is an uncaused, seemingly spontaneous quantum event. So what about that? That's not using cause and effect in physics because it's acausal, doesn't have a cause, but it does appear to happen or spontaneously come into being. So what about that situation? Well, that was proven by Dr. Hansen not to be the case in the universe. So Swedish theoretical physicist Dr. Johan Hansen in 2020 proved that these spontaneous, inherently random quantum events um, don't simply come into existence. They're actually predetermined events. And you can find his proof in the peer reviewed physics journal, Physics Essays, Volume 33, Number 2, 2020. And the basic proof he used was he applied special relativity, namely the relativity of simultaneity, to what is generally known about the correlated opposite spin measurement results in entangled particles. And he showed that under special relativity, two observers in different inertial frames of reference traveling near the speed of light, but in opposite directions towards each other, both observing the typical quantum entanglement spin measurement experiment, could um, observe a different sequence of measurements. One observer could see particle A measured before particle B, and the other could see particle B measured before particle A. And this is due to the relativity of simultaneity. This is a law of physics, so Dr. Hansen is correct. So what that means is because the first entangled particle measured has a 50-50 completely random chance of having either an up or a down spin, that means that for these two observers, there is a 50% chance that their measurement results for both particles will be inconsistent. One will see particle A measured as up, and the other will see particle A as measured down in 50% of the cases. So that's an inconsistency that is not allowed by special relativity. Um, if it, we know it would be consistent, so special relativity doesn't allow any particular frame of reference to take the lead on determining the spin measurement results. That would be a preferential frame of reference, which would also violate special relativity. So the idea that uh, a random quantum event could spontaneously come into existence was shown not to be the case by Dr. Hansen. So that can't happen. Now, if you think about these spontaneous random quantum events coming into existence, you'd realize that uh, two such events could not occur non simultaneously because that would create a time differential. And because time isn't real, because physical reality is timeless, there's a static dimension of time, but moving time, dynamic time isn't real, then it's not possible for these two spontaneous random quantum events to come into existence non-simultaneously. So for instance, if one came into existence and then another one came into existence, that would create a time differential between the two events. And that's not possible because physical reality is timeless. It's not subject to time. Having that sort of a situation would subject physical reality to a time differential, which is impossible. And so that's why you can't have these two spontaneous random quantum events occurring or coming into existence non simultaneously. However, what you can have with timeless physical reality is they can come into existence simultaneously. That doesn't violate the idea that this is timeless physical reality because there's no time differential when they both come into existence simultaneously, which means that because our universe is made of timeless physical reality, that can be that entire universe as a static block can be created simultaneously. So the whole block universe created simultaneously, but it can't be created in time. There can't be a time differential in its creation. So that allows for the creation of a whole static block universe, even with timeless physical reality. But you can't have a spontaneous, individual, random event coming into existence on its own in the universe that would subject physical reality to time, a time differential, which is not possible because it's timeless physical reality. Now, physical reality must be timeless because it cannot be changed or conserved by nature. So, because there is no cause and effect in physics, because there is no probabilistic causation that would allow for the spontaneous coming into existence of a random quantum event on its own in the universe, then physical reality can't be changed or even conserved in time, which means it has to be timeless. It's essentially frozen, um, frozen outside of time. It's unchangeable, immutable, at least in terms of nature and the laws of physics, which means physical reality has to be timeless. Now, that's the key fact that superdeterminism is actually grounded on, that physical reality is timeless by nature. That leads to the conclusions that cause and effect in physics cannot be real, as well as the conclusion that probabilistic causation cannot be real. So, uh, superdeterminism, the version that I talk about is Dr. Hanson's version, which says that we live in a predetermined static block universe without cause and effect in physics. Now, that is true. He proved it. But ultimately, it's all grounded on the fact that physical reality is timeless, which really shouldn't be that big a surprise if you happen to know something about the photon or a particle of light, which everybody knows does not experience time. So, by analogy, you already have an example of something that is like a timeless physical reality. But the truth is, all physical reality is timeless. And our static block universe, it consists of hyperplanes of space time that have the appearance of timeless physical reality on them, and they abut and intersect each other through a static dimension of time. Um, and that's all result of this basic fact that physical reality is timeless. Um, I'll give you a second to read the board. Uh, I hope you learned something and take care.